on to question 3. Let me put my scoring guideline away. Okay, question 3, just 3 parts again. Funding. One school selected at random. Attendance 1 day. Teacher funding. Daily number of absences. Okay, so we've got some normal distribution stuff going on along with some probability. Okay, so if more than 140 students are absent on the day of attendance taken, the school will lose some of its state funding. Approximately, what is the probability high school A will lose some state funding? Okay, now that's, in other words, if they lose funding, that is the same as finding the probability that, I'm going to call it X is they'll lose funding if X is greater than 140. All right, and I might want to say that X is the normal. In other words, define what X is. Random variable of student absences. See, I'm putting in context. Is that how you spell absences? Yes, it is. At high school A. Okay, now what is that probability? Well, that is a simple normal CDF question, or in other words, it's our actual amount minus the predicted amount divided by, actually, sorry, that's the probability. Let's do this. This is actually, I write this. So this is equal to the probability that Z, the Z-score, is greater than the 140 minus the predicted 120 over the standard deviation, 10.5. So in other words, you're changing this from an exact problem to a Z problem. That's really what a Z-score is. It's taking any problem, any random number, and just turning it into a Z-score probability instead. Now, what is this? This is the probability that Z is greater than, well, that's 20 over 10.5. What's that? That's 1.90. I'll say approximately. Okay, and what is that? Z being greater than 1.9. So let's find the Z value of 1.9. There it is. Now remember, this tells you the area less than. We want the area more than. So we're going to do 1 minus the 0.9713. And so it turns out we get 0.0287. Okay, that's the probability that we lose funding. And that is the approximate probability. So, hooray. So, again, for sake of time, maybe I'll fill in that we can say that it's approximately 2.9% that's high school A will lose some state funding. But I'm going to move on for now. Context, context, context. Okay, the principal's association. So just choosing 1 day at random. Let's choose 3 days at random. If the mean number of the 3 days is greater than 140, would it be more likely, less likely, or equally likely? Choose funding, justify your choice. Okay, so here's what I'm going to say. I'm going to say, since each day, or actually I'm going to say, assuming can be considered independent from, from the last if the mean absences are greater than 140. I'll say since having, I'm not going to argue this well. I don't really like the wording of this question. That's just me. Since having 1 day at or above 140 absences occurs with, say, approximately 2.9%. The odds of having 3 random days having an average of more than 140 would be less likely. Now, I don't really like my answer. I'm starting to think more about the fact that this is normal. Okay, well, we can also say this. The standard deviation of 3 days would be, and this is because I'm considering them to be independent, the 10.3 divided by the root of 3 divided by the root of its sample size, which is approximately I think this is the better way to answer the question, though it might be a little off. Find out. It's approximately 5.94, or approximately 5.95. Since the standard deviation is decreased, achieving that rare result becomes less likely. All right, in other words, if the probability that this happened when the standard deviation was 10.5 was this, the odds of it being based on 5.95 would almost be half. It would happen almost half the time. Now again, I'm not guaranteeing that that's the right answer, but it feels right to me. And I'm going to move on because almost 10 minutes have gone by. Last one. Monday, Tuesday, Wednesday, okay. It's going to be greater on Mondays and Fridays. 10 accounts occurs on Monday and Friday. Okay, just another random probability question. Probability that is not, none of the 3 days is a Tuesday or Wednesday. Again, each day is equally likely. That would be, since it's random, and each week is random. So in other words, we have 3 different weeks, and we're just trying to not choose Tuesday or Wednesday. That would happen, okay, we have 2 out of 5 is not choosing Tuesday or Wednesday, 2 out of 5, or Tuesday to Thursday. 2 to 5 not choosing Tuesday to Thursday, 2 to 5 not choosing Tuesday to Thursday. So that's the probability that none of the days are Tuesday through Thursday, and that is 0.064. And again, you might want to round that out with a probability statement of what that is, but let's get to the scoring guideline and see what we did. I'm feeling a little iffy on part B. Again, I'm here to learn with you. I'm still a student as well. Okay, so again, we get the approximate 1.9. Yay, so see how I put approximately there for that. And I got the 0.0287. Perfect. Okay, and again, I said that I should round that out with a statement at the end, and that's what they did, so definitely do that. So it would be less likely to lose funding. Now, why? Okay, awesome. See, look, they take into account that standard deviation. Now, how did I get mine wrong? Oh, sorry, I put 10.3 instead of 10.5, so be very careful. Again, that's where you go back and double check everything. I'm pretty sure I would have seen that. Okay, now they're actually comparing those with the thing. Now, I don't think you actually have to go into all that work, but there we go. And so I got the 0.064. So let's get into the specifics. Did I indicate that I was using a normal distribution? Yes, I did. Did I show the components of a z-score? Yes, I did. Did I use the correct boundary values? Yes, I did. Did I report the correct probability? Yay. Okay. Now they also go through the empirical rule, but you might not see it that way. Okay, part B. Did I calculate the probability? Would it indicate the variability is smaller and that it's centered at 120? So, yeah, I'm gonna, you know, I'm not gonna give myself much on this question. I didn't mention that the sample mean is what we're really measuring. Maybe I did, but I also didn't, well, I did indicate that the variability is smaller, but I didn't indicate that it's still centered at 120. So I think I would honestly give myself a P on this question. So that's a big bummer. Now also, I see they also show an equivalent way of getting the answer there, so definitely want to review that. That's what this whole thing's all about, reviewing. Okay, got the correct probability and shows sufficient work, so at least I got part C. So part B is part of your combining normal random variables. Now I was thinking it could have been that, and again, that's another one of those scenarios where if I had had the time, I likely would have started going into that because it's the fact that you're doing 3 days on 3 days on 3 days. So I probably would have gone this route of just doing the math because that's comfortable to me. This is definitely a hard question.